What is machine learning? Hey everyone, ever wonder how your phone knows your face or how Netflix suggests movies? That's machine learning. It's simply teaching computers to learn from examples, or what we call data, instead of giving them exact instructions for everything. Machine learning, ML, is where computers learn from data to make predictions without being explicitly programmed. Imagine you have a huge stack of pictures. Some are cats, some are dogs. You show these pictures, our data, to a computer. Instead of telling the computer, if it has pointy ears and says meow, it's a cat, you just say, here are cats, here are dogs, figure it out. Through machine learning, the computer analyzes all these images, finds common traits for cats and dogs, and learns to tell them apart on its own. The core idea, past predicts the future, sort of. The big idea in machine learning is that patterns from past data can inform future predictions. This doesn't mean exactly repeating the past. It's about finding average patterns. For instance, if we look at weather records for the last 5 years and see it rained 5% of days, we can reasonably predict a 5% chance of rain tomorrow. The computer builds a model based on these past patterns. It's like a weather forecast that says, based on past trends, there's a 5% chance of rain. It's not a guarantee, but a smart guess based on history. Information versus noise. When a computer looks at data, it finds two things: information and noise. Information is the real helpful patterns in data. Noise is the random, non-repeating stuff. Every bit of data has useful information and random noise. The computer's job is to tell the difference. Think of tossing a coin. If it's a biased coin and lands on heads 70% of the time, that 70% likelihood of heads is the information. It's the consistent pattern, but the result of any single toss, like the fifth toss being a tail, is noise. It's just a random event that likely won't repeat in the exact same way. The computer wants to capture that information, the 70% heads pattern, and ignore the noise, that specific tail on the fifth toss. The balancing act: underfitting and overfitting. This is the trickiest part. Underfitting means a model is too simple. Overfitting means it's too complex and learns random noise. First, underfitting. This is when our computer model doesn't learn enough information. It's like trying to guess why a bank customer leaves. This is called churn, just by their age. You'd miss vital clues, making bad predictions. The model is too simple. Then there's overfitting. This happens when our model learns too much from the past, even the random noise. Imagine it memorizes every tiny detail about previous customers, even their odd habits. When a new customer comes along, the model applies these random quirks, leading to bad predictions because the noise from the old data doesn't apply to new situations. The goal is to build a model that's just right, smart enough to get the true information, but not so smart it gets confused by random noise. This balance is key for accurate predictions. And there you have it. A quick look at the core ideas behind machine learning. It's all about intelligently learning from the past, separating what truly matters, that information, and avoiding pitfalls like underfitting and overfitting to make really smart predictions. Thanks for watching, and stay curious.